You know I'm a fan of Six Sigma, but I don't really like DMAIC for problem solving, and there's a good reason that I'd like to explain to you. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video, it's about why I don't really like DMAIC. Now don't get me wrong, I do like the system when we are improving things, when we are reducing the variability in our processes, but not for problem solving. Now, of course I knew about this method, right? But the real trigger was that Paul Allen, he launched a course only a couple weeks ago. I'll put the links down below, put a card up. It is a really nice course to follow. I'm actually very happy that I bought it as well, and I'm now breezing through it. And he explains the DMAIC in a very nice and structured way. Also, he includes all kinds of tools for each of the phases that will really help you. And he says problem solve. Well, there, Paul, I don't fully agree with you. I think you are teaching us a brilliant way to reduce variability in the process and to really go for improvement, to really make the physics around the process, but by that, the process a lot better. And that, to me, is not problem solving. Now, one of the first things when you're going into DMAIC is that you define what the problem is. Okay, yeah, I can understand where problem solving comes from, and then start to measure what is really happening. And basically also the first thing that Paul advises in his course is to check what kind of problem are we dealing with. Now, the base idea of beginning with something that you do not really like, that of course is good. But then what two types of we don't like it come up? And he uses one of the best examples to make that split. I've also done this with run charts. You can do this with all kinds of problems, deficiencies, variation stuff. Here we'll use basically a histogram, right? And the first thing we take attention to is, do we have a problem where we create, and here we create defects, right? That's the basic premise of this kind of defining a problem. Are we just doing a process that has so much variation in it that we're making, well, sort of literally making problems left and right, but the bulk of the process is of course good, right? But on both sides of our distribution of products that come out of the process, we're going over the tolerance limits. So here we are producing products that fall under the lower specification limit. So they're defects. We're also producing products that go over the upper specification limits, defects as well. So in other words, our whole process has a variation built in, has a spread of what comes out as products that is wider than our specifications. The other type of problem that we see is where we know that, well, basically the process is capable. CPK, we know that's right, the CP and the CPK. So the CP is pretty good. The capability of this process is pretty good because it could have fit between the specification limits. But here the process has shifted and we are producing defects on one side, in this case only under the lower specification limit. Now, why is this such a big thing to immediately define and measure in those first steps of the DMAIC? Because this type of problem will take you 3 months and a serious team of experts to solve. This might take you 3 hours or 3 days. It depends a little bit, there are sort of the in-between problems where you've been trying to get this corrected and it just doesn't really work, where it may cost you 2 to 3 weeks. But this is a relatively simple problem to solve. This is a pretty darn difficult problem to solve. Here we are actually speaking about reducing the variability in the process, or as I would call it, it's one of the ways of seriously improving your process. Here we have a shift, something deviated in our process, and that deviation, that is what I define as a problem. So here we also have a root cause, usually. Sometimes you have 2 root causes. Sometimes this is just something that has been there for quite some time already, but 90-95% of this type of problems, you can actually find that one, maybe two root causes and eliminate it. 90-95% of these cases, you have to dive into the physics of the process itself and really do, and in Paul's course this is very well explained as well, but really check which variables are giving stability or variance. Do a designed experiment to see, what is the most stable way we can let this process operate. Do also a good analysis, the type of sort of a fishbone analysis, but then really a cause and effect type of analysis where you put all the cause-effect relationships around each of the processes in and judge them on, are they stable or not stable? Are they in control or are they giving noise? Or don't we know? Now, that leads into really going through all of those steps. But to me, that is not problem solving anymore. So yeah, you can say you are solving a problem, but this is really an improvement of a process. That is not something that was performing brilliantly and now suddenly there is a problem. And the thing is, the DMAIC tries to capture both of them. And in fact, what you then see is that in these first steps, in this define and measure phase, you check which of those are we dealing with, and based on that, we select the tools that we'll use in the next step. And I think we can shortcut that. I think that following, let's say, the 80-20 principle, where you just do things first and get most of the result, if you run a good performance process control cycle, you will have a darn good idea of which of these problems are we talking about. And that's one of the things I explain in my course on problem solving as well, and in some of the videos. When you know that it is suddenly a dive away from your expected performance level, then 80, 90, 95% of the cases we're dealing with such a problem. So when you know that, take the chance and go for the 6-step problem solving method, because that will usually solve it. Now, if in the definition, in the root cause analysis, you still see that we are actually dealing with something like that, you can always shift back, go to the problem owner and say, look, this is going to be a more serious project. We're going to need different tools, probably also different people. But that will be the less than 10% or so of those cases. So don't take this full DMAIC system onto the problems where you are already 90% or so sure that we are dealing with a single root cause. In the end, if you are a good black belt, if you are trained in Six Sigma at all, let's put it like that, and you know the DMAIC system, you know also the tools that fit under several of these phases, you can solve it. I mean, I trust you in that. You've been trained. The thing is, this does not give you a helpful structure, right? You still have to decide yourself which tools to pick, how to do it. It's sort of iterative from time to time. That, I mean, it might work, but that does not give you the best chance for success. It's brilliant when you're improving, when you're defining new things, when you're really getting into the process, and when you need to do that analysis, improve, control, analyze a bit more, improve a bit more, make sure that it stays in your organization. But when you know already that you're probably dealing with that, get a team that is well suited for such a problem. Define what really happened. That's almost the same. Get some temporary fixes in place, something that the DMAIC seems to forget totally, which in the long run, I mean, you should take them away again. But we're talking about a quick problem. We know already that we had a standard level that was better. So with some quick temporary things, we can probably at least get things back to sort of standard, usually more expensive. Then we dive into the root cause analysis. That is basically the same as we see here, but because we know that we are looking for a deviation with almost certainly a root cause, we preload that you're going to do a fishbone that is not too complicated, really stays on top level, how we do that in a structured way, helping the team. And from that we lead into a 5 why analysis. Again, because 80-90% of the problems will be easily solved using that system. Then we define countermeasures based on everything that came before. That is quite linked, quite similar to the improve phase. And then we sustain those changes in our daily operation. That is pretty similar to the control phase. So you do see that the basic phases are almost the same, but when you know that you've got such a type of problem, pick my simpler 6-step problem-solving model. Use the template as well, because in more than 80%, I would say 90% of these cases, it will just lead you through it. And that means that your speed of solving problems will go up dramatically. Now, for those 10, maybe 20% of problems where it's not the most ideal tool, get your black belts or your real problem-solving champions involved. Actually, I think if you've done a couple of my problem solvings like these and are watching videos by me and other lean and continuous improvement people on YouTube, you can also do that. But get your basically your black belts involved, and those problems you upscale, you escalate. But if you do that for every problem and improvement and everything that you would like to change, including the deviations from standards, you will be wasting time and valuable resources. And that too is a waste. So that is why I don't like DMAIC for problem solving. And I advise you to also master this much simpler, much more group involving way to problem solve deviations from process standards, performance standards, or skill management standards. Now, I still recommend that you check out that course by Paul Allen, because it really gives you a good method and a good overview of the quality tools, of ways to improve your business. Very valuable. But for the problem solving that you put on deviations, check out my method, download the template. You know, I've also got a course explaining this part, and I'd be happy to coach you through it as well. So get that quicker method to maximize how fast you can be on your standards again, how fast you can problem solve in your organization. And whatever way you choose to improve your problem solving, I wish you the best of luck with that. And don't forget to also enjoy the continuous improvement journey.